is grown here. And we have at the bottom weighing arrangement or weighing mechanism to measure the weight with time. So there are, as you know, two types of lysimeter, weighing type and non-weighing type. Weighing type lysimeter gives you all water valence components information. Just like in this profile, soil profile, change in soil moisture, soil water content is simply how to find out. It is basically any irrigation we are adding, any rainfall it has occurred, then minus any drainage loss, minus ET, that is loss, and minus any runoff if it is there. This is rainfall and this is runoff. So addition, irrigation and rainfall. Negation means going out as a moisture. So drainage, it could be at the bottom. It could be ET, that is lost from this area, or it is, if it is excess water, that is runoff that has generated from this area. So if we know how much it has been added as irrigation, if there is any rainfall, if we measure what is the weight, simply change in soil moisture, that is the change in weight of this system, that is weighing mechanism we have. And if we have measured from the bottom any drainage loss, any surface runoff from the top, if it has gone out as from the aided water condition, we can find out the ET. So ET is simply irrigation plus any rainfall minus change in soil moisture, or that is basically weight, minus drainage and minus runoff. So in this way, we know that any addition, we know the change by weight, we know the drainage which is measured from the bottom, and if there is any surface runoff, we have measured from the surface condition. We can find out what is ET of this particular crop which is grown in this tank or lysimetric tank. So this is the simple idea, and if you want to have very clear idea, means how it works, suppose there is a system, initial weight was W1, and suppose we are adding as irrigation simple amount, say 5 millimeter, 5 kg, let us take in weight unit, and it was W1. It has D as drainage, suppose it is say 3 mm or 3 kg, then it is the second weight W2. So what will be ET here? ET is simply change in weight. So W1 minus W2, whatever it's positive or negative, plus addition, that is I, minus it is D. Basically, rainfall is 0 and runoff is as well 0. So in that sense, we can calculate, suppose it was initial weight of 100 kg and final weight is, suppose we have measured 101 kg. So you can find out it is addition W1 plus 5 here, it is 100 minus 101, that is negative 1 it will be, plus irrigation that has been 5, and drip percolation or drainage it is 3. Oh, sorry, it is minus. So it is just one weight of water or millimeter, whatever you want to measure it finally, it is in evapotranspiration from this system. Now to measure this, you have learned that lysimeter is a device that is used to determine evapotranspiration. There are two types of lysimeter, weighing type and non-weighing type. We are simply trying in the lab condition to understand a weighing type lysimeter. By the way, there are different methods. Let me remind you, there are different methods to find out evapotranspiration, in which, if you recall, we have taken first idea, direct measurement, where lysimeter comes, means it's measurement. Lysimeter from the field itself or field condition or experimental condition. Then field experiment plots where we are simply trying to find out change in soil moisture. That we are simply assuming that in a season, change in soil moisture is simply ET. Then soil moisture depletion study from the field itself, that is cumulative on daily condition. If you recall your theory learning, there were all these methods I told you. So direct method, that is lysimeter, field experiment plots, soil moisture accumulation or depletion study, and finally water balance, that is for a big area like a basin we have. Then it comes estimation, that is the second approach from the pan evaporation data. Pan evaporation data, there are two types of pan. Standard US pan that has a kind of relationship ET0, E0, that is evaporation from the pan, and ET, it has a relationship near about 1.2 to 1.5. And second, it is sunken pan that has a kind of relationship evaporation versus ET, it is equal to 0.95. So this gives an idea about pan constant. And finally ET, if we want to estimate of a graph, ET is equal to E of pan into K, that is constant of pan, into Kc, that is crop coefficient, to find out ETC. So pan evaporation into K means pan constant, and Kc is the crop coefficient for different growth stages of the crop. We can find out ETC, evaporation of that particular crop. So first method is direct measurement, second is based on pan evaporation, and third method is as well there to find out ET of the crop, that is estimation from the climatic data. That have different methods like Blaney-Cradle method, Thornthwaite method, then Penman method, modified Penman method, Christiansen method, and LR. So here we are simply trying to understand direct method of measurement by using Bain type lysimeter. Bain type lysimeter, if you have gone through the writer, it has simple fitting or arrangement in the field, but in the lab condition we have a weighing platform that is using a hydraulic head, and that's why it is hydraulic valence. Basically we are simply telling that we have a tank like this which is filled with sand, simply resembling that this is the field condition soil. We do not have any crop for understanding in the lab. So aiding of water, it is assumed to put the bait there. Weight each of 200 gram. So these 200 gram bait are put in an order on this sand filled cylinder, which is assumed or resembling simply the lysimetric tank, and these baits are simply showing the addition of water in actual field condition, and we are measuring the weight by a hydraulic valence or simply the head of water which is connected from the bottom. That is basically the pressure which is generated because of addition of these baits resembling the addition of water in actual field condition. And this angle of manometer we are changing, maybe from 5, 10, 15, 20, 25, 30 and so on. If we are changing, what will be the height, or say this L, basically length of water rise in this tube when it is inclined to a certain angle, and making a relationship between this inclined angle manometer tube length, which is showing the head of water at different addition of weight, and the same removal of weights, that is basically showing the ET. So addition of the weight, irrigation water addition to the lysimeter, and removal of weight is simply evapotranspiration. That is, we are resembling from this arrangement in the lab experiment. So now this is more detail how it is fitted. This is the bottom. This is weighing platform. We can have a plate and we can put here a container which is filled with the soil, same soil which is in the field, to grow the crop or to grow the plants and to find out how much water it is used within this area, so that we can estimate what is the actual loss of water as evapotranspiration from the field. Now experimental layout, it will be fitted, means it is shown in the video I have shared you. And finally, once you have observations for different manometer angle condition, length of water in this manometric tube, we can find out a relationship between weight and length of manometric tube water in this tube. So observations, we need to find out the weight of lysimetric tank with soil. So if we have the idea what is the diameter of this and what is the length which is filled with sand, we can calculate the volume, and if multiplying by density, it will give you the weight of soil in this cylinder. So if we know the diameter of sand filled cylinder, height of the sand that is filled in the cylinder, density of sand, please means write down, that is 1.5 say gram per cubic centimeter that we are going to use, 1.5 gram per cubic centimeter, that is the density of sand what we have used here. Then we can calculate back weight of the sand in the cylinder. So we can find out volume of cylinder, and if multiplied by the density, it will give you the weight of the soil or sand in this cylinder. And then observations we need to take for different angle, 5, 10, 15, 20 and 30, suppose here. So I have given observations for 10, 20 and 30. You need to note down the observations from the video for 15 degree and 25 degree, that is shown there or discussed there. When we are adding bait, means from no bait condition we are starting. So what is initial level of water in manometric tube, and then we are adding 200, then 400, then 200 plus 600, then 200 plus makes 800, and so on up to 2 kg or maybe 2400 grams. Reason being, at 5 we cannot go here to more than 2 kg something. Then if we are increasing the angle from horizontal, it can means we can put more weight to show in the manometric tube the level of water. So when we are loading, we need to find out what is the level of water in manometric tube, and from the last we are removing one by one in the same way, the way we have added the weights here, so that there is the least disturbance to the system. So from suppose 2 kg or 2000 gram weight, we are removing one, so reaching to 1800, then 1600, 1400, 1200, 1000, 800, remove 200 gram more, and finally reaching back to zero load in the lysimetric this tank. So what does we will see that while we are adding the weight, it is showing a different level in YouTube, means in manometric tube. While we are removing the weights and reaching back to zero condition, it is showing a different level of water in this manometric tube. Why? It is simply the characteristics of balance, because it's made of rubber tubes. So tubes are, when pressurized, automatically it is means like this, balance is like this. It's a rubber tube filled with water on which this tank is fitted, or this cylinder is fitted, and this is connected to U tube. manometric tube here, not U-tube, but simple manometric tube. So this characteristics of tube, which is simple tube, it's showing the difference in addition and removal of the bait at the same level or same bait condition. There will be a difference in height of water or level of water in manometric tube. So this is, we need to understand that this is the characteristics of balance or limitation of balance. Hysteresis you have learned in soil. At the same time, any system shows a difference when it is heading or soil moisture is added there and then soil moisture is removed. If you recall, even soil moisture characteristics for the same, it is addition and second it is removal. So this difference is head condition in even soil. It is called the hysteresis losses of soil moisture removal condition. So once you have understood this, you can plot the results in terms of plot graphs between manometric reading, that is in centimeter, versus loading unloading weight for both. One is for loading, so another will be for unloading. Here it is touching from the zero, or maybe it's different. At least from here it will be the same. And calculate the slope of curve at time of loading and unloading for each angle. Suppose 5-degree angle, 10-degree, 15-degree, and so on. So what is the angle? That is theta. So tan theta, that is simply y by x. You can find out what is the slope of this loading and unloading condition in the manometric tube. So it is simple explanation why it is difference in loading and unloading height of manometric level. This is simply because of the flexible characteristics of rubber tube, or just like if we are using a spring bait, so it has also a kind of constant. It takes some time to go back to its original condition, and that's why there is a little difference in any system nature. It shows the same. That is called the hysteresis losses because of the system condition. Now these are the precautions you can see from the write-up file I have sent you, and you can watch how it's basically looks like in real system. If you just watch the video, where it is, do you know where it is? It is in file section. I put there. Can you see please? That is files, uploaded files, class material, and experiment number 9, Lysimeter. Can you please see whether it is downloading? Or it is opening?
Sir.
It is opening?
Yes sir, it's opening.
Okay. That is near about 15 minutes. So let us meet again. And in the meantime, I will update the observations, but you need to note down the level of lysimetric head or lysimetric reading for loading and unloading condition of 15-degree and 25-degree angle of lysimetric tube. What it is discussed in this video, or it is shown, or I am simply telling in this video. And other observations for 10, 20 and 30-degree angle I will give you in the file, or in the observation file I am going to share it. So okay, so for 15 and 25-degree angle of lysimetric tube, you please note down the observations which are shown in this video. So please watch, and let us meet again at 3:20. It is 3:03. So 15 minutes or 17 minutes, just check video is working, and we will meet again at 3:20 to discuss about the observations. Okay?
Okay sir.
Okay, please watch. So now you can see this is the setup for lysimeter. Here you can see this is the platform which has a weighing mechanism. As I told, you can have any type of weighing mechanism. starting from Wheatstone base, resistance based spring condition. Here we have a hydraulic balance. A tube is filled with water which is connected by using these thin tubes, and here we have a scale which measures the head of water. So this is basically a kind of condition where we can say we have a hydraulic balance. This is the Lysimeter platform which is standing on a tripod stand basically, but we do not have tripod stand to support this heavy weight, so we are fitting this everything on three table, means wooden platform. You can see first it should be a balanced condition. So you can see it is balanced platform on which we will place a cylinder which is filled with sand. So this is complete setup for weighing type lysimeter, and this is replicating a kind of condition which we have in the field. It is not in the field, but we are calibrating simply by putting the weights of 200 gram each, as I told. So once we are putting the 200 gram weights, it is simply resembling the addition of irrigation or rainwater in the field, and we are observing what is the head. So that is simply the weight. The condition, we are removing the weight, it will give us an idea the water loss from the system because of evapotranspiration. That is our target here. So we need to find out what is the characteristics of addition of water or addition of this weight and removal of the weights or removal of the soil moisture from the actual field. So these characteristics, if we are developing as a calibration condition in the actual field, if we have the weight or say simply the hydraulic head here or the final weight in the field, that we can find out what is the soil moisture condition in the field. So that is our target, and the difference of these two will be the evapotranspiration. So we can find out what is the daily or conditional with time, the rate of loss of water from the field because of the process evapotranspiration. So let us put the cylinder filled with sand, and before that we need to find out the measurements. Yeah. So this is the complete setup. We have weighing platform with hydraulic balance. We have sand filled cylinder that is resembling the container filled with actual field condition soil, and we need to find out what is the initial weight. So initial weight we can see here that whatever it is the initial condition, that is suppose 50. What is the angle of this inclined manometer, open manometer? That is 15 degree here. We are taking just one example from this array. This is 15 degree. So we can go for 5 degree, 10 degree, 15 degree, 20, 25, 30, just for an idea. So observation data I will provide you for at least 3 inclination angle of this Lysimeter balance arrangement. Initial condition, we put here cylinder, and we need to find out what is the initial weight of this setup. So let me see what is the size of this cylinder. So you can see here we have a size that is 24.5 centimeter is the height. What is the dia? Let me see, rough method just like here. Okay, I am going that side. So here we can see maximum where it is here. So this is 24 exactly, 24 centimeter is the diameter, 24.5 is the height, and it is filled up to, okay, here 2.5 centimeter. So the cylinder is filled up to 22 centimeter with the sand, and if we are taking 1.5 gram per cubic centimeter the density of this sand, we can find out what is the initial weight of this cylinder soil. And the initial head is, okay, 60 here. 60 in the YouTube. So we can find out the moment we are adding the weight here in distributed manner, how this scale will increase, and when we are removing the weights, that will resemble the use of water from the actual soil condition by evapotranspiration process, it is again reducing the weight. So it should be theoretically equal scale for the weight condition when we are adding and when we are reducing or removing the weights. So let us see whether it is following the same or not. Let us see. So here it is weight, let me put 200 gram. So it starts from 60 to somewhere 60.2. Let me put my glasses. So it is exactly 80.2. So it was initially, you can see again it was 60, and now once we are putting, it is somewhere 80.2. Okay, now put another weight, second weight, it is reaching to 100.1 or 2, 100.2. Third weight, let me put here, and it is reaching to 120, exactly 120. Fourth weight, let us see, it is 800 gram we have put or added water. The scale is somewhere 140.1. So fifth weight, it is 1 kg addition of water. It is 160, 1200 gram. Sixth weight, 180 somewhere. Then 1400, reaching to 200 somewhere. And in this manner, it is 1600, 220 or less than 220, 219 somewhere. Then next we are putting here one more, that is 1800, and now it is 2 kg weight. Once we are adding, it is reaching to near about 256. Now let us see, if we are removing the weights, what is the reading? Let us start from where we have put the last one. We are removing here. It is reduced, but it is not reaching exactly what it was showing. So you just see 246.45. Another weight we are removing. This is again 230, but it was something different. The third weight we have removed, it is reaching to 210 or 213, 1213. Now you can see we are removing one by one all these weights slowly, and it gives a reading. So this resembles the removal of soil moisture from the field in the process of evapotranspiration. And if we have characteristics of such kind of soil property, then we can see that it is, we can find out it is the rate of soil moisture removal by the process of evapotranspiration. So now it is the last weight remain as 200 at present, and scale is somewhere 96. So last weight if I removed, this is the characteristics of this scale, that is giving you near about 76, but we started from 60. So this is the characteristics of addition of water and removal of water at 15-degree manometric angle. If you want to see one more, let me show you one more observation, and then I will give you observations to find out the characteristics curve of this lysimeter. Okay. Now let us see. This is new angle 25 degree. Why we are changing this angle? When this is lesser angle, sensitivity of this scale is higher. For the same weight, more divisions will be covered. When we are increasing the angle, sensitivity is reduced. So now see, let us start for 25 degree manometric angle. The starting reading is now somewhere here 45. You can see 45. So let me add the weight here. One weight just 200 gram, and it has reached to 60, near about 6 or say 58. 58. Now the second weight 400 gram if I am adding, it is reaching to 70 or 71. 71. Third weight 600 gram, it is somewhere 84. 84. Fourth weight, it is 800 gram we have added, it has reached to 95 or 96, 95, 96. And this is just 1 kg. Fifth weight I have added, it is 108. 108. Now we add few more weights. Let us see. This is sixth weight, 1200 grams we have added, it is 121. It is 1400 grams we have added, it is 132. It is 1600 gram, one more weight we have added, it is, new reading is 145. One more bed we have added and it reached to 156. One more bed if we are adding, it is 170. And now it is 1800 grams we have added, it is reaching to 181, and it is exactly 2 kg we have added, it is 192. So now you can compare between 15 degree and 25 degree. Its sensitivity is reduced now because less number of divisions have moved for the same 2 kg weight. So I am adding one more weight. It is 2200 grams. It is reaching to 205. One more weight, 2400 grams. It is reaching to 215. It is more weight. It is now reaching to 229. Now let us remove one by one all these weights. So first weight if I am removing, it is not exactly the same what we have added. It is 220, right? So it is little more. Second weight if I remove, it is 210. It is next weight if I am removing, it is 190. See, it was earlier 95 and now it is 98. Now removing more weights, it is reaching to something next scale. More weights we are removing, it is 174. One more weight if we remove, it is 162. So in this way, if we are removing weights, now you can see more weight 150, 136, 37, more weights, it is 125 near about, 200 removal it is giving 113, again 200, it is 90. 100 exactly. Now it is 200 further removed. So it is 88 somewhere. One more we are removing and it is 76. One more bed we removed. It is 65. And finally all the weights now we have removed and reading is somewhere 50, 52. 52. So you can see we have started from different reading and we reached to reduced condition. So in both ways, addition of weight and removal of weight gives different reading. This is because of the characteristics of the tube. It is filled with water, and you can explain it by hysteresis losses. You might have learned in your second year. So this is the idea to find out the calibration curve of a real setup of lysimeter, so that the moment we have measured the weight of lysimeter, because it's a weighing type, we can find out what is the content of soil moisture that has been used as evapotranspiration. So I will give you observations for other angles, so you can find out the characteristic curve or calibration curve, and also find out the rate of change, that is tan theta. That's all.
Hello, sir.
Yeah.
Yeah, we have watched it, sir.
Okay. So do you have any query, confusion or question if you have? Anybody?
So the 25-degree readings are not clear.
It's not, your voice is not clear.
Sir, hello, I'm audible.
Yeah,
So the 25-degree readings are not clear.
I'm not clear. Can you please make it a little louder? What do you want to say? Yes, please. Anybody has any query? Yes, Utkarsh. 25-degree readings are not clear. Okay. So try to go through more time this video and find out. I have observations, though I also have written this. One or two may not be very, means I am not telling, but it is shown in the scale. So you just watch one more time and observations you can get. And three observations you can see here. I have given where it is here. Can you see my file, Word file? For 10 degree, 20 degree and 30 degree, I have uploaded this file in your document section. So three observations for 10 degree, 20 degree and 30 degree, it is given here. Take the density of sand, bulk density, 1.5 gram per cc to find out the weight. Everybody please. And try to fill out two observations, 25 and 15 degree manometer angle from the video. Just watch one more time and near about observation you need to put there to find out a relationship. So this you need to do it. Is it clear? Somebody is writing something.
Sir, I don't think you have uploaded it, sir. We cannot see it actually.
I think I have uploaded this. I think. Let me see if the file is there. Files, class material, I have uploaded experiment 9, lab observations, lysimeter. Can you please check? Documents, general, class material.
Sir, yes, sir, uploaded.
I have uploaded this. Okay. So these observations are available to you. Try to fill two observations for 15 degree and 25 degree from the video and prepare your learning as it is asked. Is it okay?
Yes, sir.
Okay.
Yes, sir. Okay, sir.
Okay then. Yeah. And next 4 labs in 2 weeks. 4 effectively there are 1, 2 and 3 effective labs, and fourth one is to learn about the components of drip and sprinkler irrigation. its arrangement, its component, drip and sprinkler irrigation like drippers, sprinklers, filters, and so on, how and in which order they are arranged in a system. Then second, it will be uniformity of sprinkler irrigation. Then it will be uniformity of drip irrigation system, how to measure in the lab, and how to use Venturi to supply or inject the fertilizer or liquid fertilizers or chemicals. So Venturi, one experiment. So in this way, there are 4 experiments are remain to complete in 2 weeks, next 2 weeks. That will be on 21st and 28th. And then after it will be a test and bye-bye. So let us complete everything in next 2 weeks. Learning on drip and sprinkler, 2 are remain, and then we will be completing this lab class. Do you have any query? Any type from theory or here, you can ask. Otherwise, you are free now to complete this lab experiment and submit by midnight Saturday. That is 19th. Is it clear?
Yes, sir.
Okay.
Yes.
Okay. Then see you.
Thank you, sir.
Okay. Welcome.
Thank you.
Thank you, sir.
Thank you, sir.
Okay.
Sir, can you conduct one field trip, sir? Optional field trip.
You are
For,
here.
yes, sir. For those who are willing, sir.
No, it's perfectly fine. No problem. I can show you different irrigation arrangements. So if you are here, when can we meet?
Sir, any day, sir. Any
I
Saturday, whenever you're free, sir.
Sir,
Saturday.
Day or something.
I will talk basically sprinkler and drip irrigation. Professor K.N. Tiwari. Earlier he was teaching, but this year lab as well as theory I am completely taking. So I will talk to Professor Tiwari. Next to experiment, he will explain you drip and sprinkler. So if you are first, I will talk to Professor Tiwari, right? If everybody is interested, we can have these 2 labs. If you are interested, otherwise we can go online. We can have physically sprinkler arrangement in the field. I will first find out.
Sir, we can conduct in hybrid mode, sir. Those who are willing can come to the field.
It's only means then what I am thinking, if you want to see at least 2 experiments working on real condition and then go to the field, I can arrange that as well. But if you are interested to make a field trip, then next Friday we can have, next Monday after lab, maybe at
Yes.
4:30 to
Yes, sir.
5:30
Yes.
we can go and see. Is it fine? I will talk to Professor Tiwari because next 2 classes he will take. Is it okay?
Okay, sir. Yes,
So
sir.
I will talk to Professor Tiwari and let you know if we can have a field trip on Monday, next Monday, means after lab is over online. So you will have means maybe up to 4:30 maximum. So you can assemble 4:30 and then we will go walking to see different arrangements in the field of these labs, what we have performed. Is it fine?
Yes, sir. Thank you,
Okay.
sir.
Okay. Welcome. Okay. See you then.